Hello everyone, welcome to VizConnect, connecting you with the art of data visualization and storytelling. My name is Sagar Kapoor. I'm part of customer success team at Tableau. So VizConnect is a global weekly Tableau community which helps you to connect with the art of data visualization and storytelling. It's a platform to get inspire, motivate, and learn how you can go ahead and upskill your Tableau skills and data visualization skills. We have a YouTube channel, so all the sessions which are presented in VizConnect are uploaded to a YouTube channel. Go ahead, subscribe to it. We have a LinkedIn group. Go ahead, connect with each other and learn from each other. Also, we just go ahead and follow the hashtag VizConnect on Twitter just to go ahead and update with all the latest we have. With that, Tableau Live is coming both in Europe, Asia Pac, and America. So on 6th May, we have it in Europe. On 11th May, it's in Asia Pac, and on 18th May, we have it at America. Go ahead, subscribe to it, register yourself, some great content across the globe coming from you, and get a chance to go ahead and connect with each other in the community and learn some best practices in what's coming new in our product. And I'm also presenting in one of the session in Asia Pac, just talking about how to build a data culture to propel faster decision making. Along with me, we have some great line of speakers. So please go ahead and register for this Tableau Live session. Also, just wanted to give a shout out to Mentoring Meetup. If you are someone who want to go ahead and mentor people, if you want to go ahead and help them to start with their Tableau journey or data visualization career, just go ahead and apply for Mentoring Meetup and be a mentor. With that, let me just go ahead and introduce our speaker for today. We have Mitsuyasu and Jim. So Mitsu is an analytics manager with 10 years experience in logistics, supply chain, cost, production, sales analysis, mostly in construction industry. Tableau is his weapon of choice, both in professional and private usage. Developing visualization is not only his career path, but also life passion. With that, I will hand it over to Mitsu to talk about dissecting Viz of the day, space ray. Over to you.
Good morning, everybody. Let me just share my screen. Okay, so can you see my screen?
Yes, I can see your screen. Please go ahead.
Okay. Good morning. I will talk today about dissecting Viz of the day, space race, which is a visualization I designed quite a while ago. It was selected Viz of the day. It was my second pick as a Viz of the day. And I would like to talk to you about inspiration, sourcing, preparing data, chart selection, designing, and compiling all elements together. A little about me, like Sajar mentioned already, I'm an analytics manager with around 10 years of experience, mostly in logistics, supply chain, and sales analytics most recently. I started my journey with Tableau Public around 1.5 years ago when I discovered Makeover Monday initiative, which really helped me boost my skills. Since then, I participate regularly on a weekly basis because for me, being an analyst or someone who is visualizing data, it's like being an athlete. You need to practice on a regular basis to keep shape and to be better and better. And that's why these initiatives like Makeover Monday or Iron Quest or Sports with Sunday are really great and help me, be consistent and public visits on a regular basis. Okay, so let me briefly go through this visualization, which I will talk about on Tableau Public, and then we go through all the phases of designing and publishing. So first of all, subject I think is quite interesting, because when I started exploring this, it turned out that the recent years are like going back to space race, because we had a lot of space missions in the 70s. Then it was a little slowdown until late 2015, maybe 2016, when China, I think, participated more in this race. So we have a timeline of all space missions since 1957. Below we have split per country, and on the right-hand side we have a bar chart with countries and how many missions they performed. Russia and USA are here. Below, what is interesting, we have a map with all launching pads or launching facilities around the world. And here we have line or bar chart for those who, for which the most launches took. And of course, we have something which looks like a planet or a Death Star, I think, or some kind of sun. It's Voronoi chart with share of organizations which performed missions to the space. Okay, so let me start with inspiration. Inspiration to this viz was viz done by Dorian Banutoi for Makeover Monday, week 14, 2020, which is a great viz. When I first saw this, I knew I had to find out how was it designed. I mean, these spikes quite unusual to see on the maps. So I started to digging in how to recreate this, and after I done this, I was looking for some kind of theme or data which I can use this technique. Then I came across this dataset on a Kaggle performed by Claudia Marola. This dataset, all space missions from 1957, because it was updated quite a while ago. I needed to download some more fresh information. Fortunately, the site which is source of this information is not in any kind of database format. This means I had to do this manually. But it was not so many records, and I was able to complete this dataset until October last year. Okay, so next step, I will move to the Excel and then how I will build this visualization in Tableau. So raw data looked like this. We have a company name, location, date in some strange format. We had details, status, and status of mission, if it was success or failure. So before I could, jump into Tableau and start visualizing it, I needed to add some information. First was coordinates of facilities or launching pads. We had around 45, 44 exactly launching facilities around the world. So I need to download coordinations of these locations. I also added some information about company origin, and then compiled this data together along with some modeling, like extraction of location, date together from these three And then move to Tableau. As you can see, some of these charts are quite straightforward, because it's not bad if it tells the story exactly like you want this. So first one is simple bar chart with timeline of space races since 1957. If you hover over each bar, you will see two donut charts with a split between success and failure of each launches during each year, and split per country. So here you can clearly see two phases. First boom in 1960 and 70s, and one recently. The chart below is quite interesting, I think, because it looks like mountain rocks, for example. Here we have split by country. You can see that Russia was fueling this space race until 90s. Then USA took over, and recently China looks like this chart is something which is called stream graph. I followed great tutorial by Ludovic Tavernier from Gratified, and it is a great tutorial. And if you want to use stream graph or sigmoid bump chart, it also has this name. Then it's great to follow this. The right hand side, we have total numbers per country. It is simple bar chart with Jant bar at the end. And here is also a trick which I picked up from Lorna Brown, I think, is how you can modify the size of Jant bar by putting some number into size. If I remove this, we have slim bars. In this case, we have a more visible one. 9 out of 10 attempts were successful. It's also interesting information presented on a donut chart. So we have 4,342 launches, and 10% of them was failure. And if you look at the timeline, you can see that most of them happened at the beginning of space race, which is quite natural, I think. Section below, I will start with a map. Map is custom Macbox style, which is quite cleaned. Only have no boundaries of continents, watercolor, and base color. As you can see, it also have lines which starts in location of each launching pad and ends in the sky. If you want to, somehow start with Mapbox, I highly recommend to start with a great tutorial by Jonathan Walker, where he's instructing how to start with customizing maps in Mapbox. It's my starting point, and it's a great material. The second part of this section is line chart or bar chart. No, it's line chart combined with shape. Here we can see which launching pads had most launches. As we can see, so in tooltip we have a breakdown by country. Why I chose to do this section in a two, not one way? Because if I would put these bars, which will start at some point on Earth and end somewhere in the sky, it will be hard to compare size of this bar with another one, because it would start in completely different place. So it would be hard to see at the first glimpse of an eye which are the most popular launching facilities around the world. If we do this in a same common ground or starting point, which is here marked by 0, we can see that there are 3 most used facilities around the world. One of them is in Cape Canaveral, USA. The other is in Russia and Kazakhstan, I think. It's Baikonur. So the last element is this Voronoi chart, which I used template by Tristan in. It's also great material, great tool, because only by uploading your data you can extract Excel file which you can import into Tableau and easily build this kind of visualization. So whenever I use Voronoi, I always use this data generator. It is really great tool. And altogether, this I think is all of this which are building this visualization. Maybe one more thing, font used here is Android 101 from Data Font. I also used Gold PowerPoint to to create this shape in the background, and I think that's it. That's it from my side.
Perfect. Thank you, Mitsu, for sharing all those inspiration and motivation with everyone. One thing which I have seen in all your bits and pieces of visualization, you have taken motivations from everyone, right? So can you just talk about that? Like, how do you do that? You just go to Tableau Public. If you like something, you do reverse engineering and learn from there.
Yes, generally the most inspiration I take from Makeover Monday, because you have a ton of inspirational charts or visas coming to you every week. And you know, when you start to see these things, then you start to build some kind of this catalog in your head.
Yeah.
Then if you want to use some of them, it's like, you know, building something from a bricks. So we have an amazing whole data farm is producing a lot of amazing tutorials how to design the most complicated charts inside Tableau. But in the end, it's your job to, you know, combine this together to make it look like a part of whole. So for me, most inspiration I took from Makeover Monday.
Thank you. And I'm hoping to see more Viz of the Day from you.
Yeah, I hope so. I I hope so. I'm trying to as much as time allows me to.
And one just last question from my side. Like, as you mentioned in your introduction, you're working as a analytics manager, right? How do you differentiate your dashboards which you design for work and something like space trace, right? Like, h- how should we go ahead and be creative when we are designing business dashboards, or it has to be more specific to the information our executives are asking about it?
So generally, these are two completely different things, because in our professional work have some ground rules we need to follow when designing dashboards. And if we go to something like this space race, we can go nuts and try some different things which maybe not are the best practices if we're talking about designing business dashboards. But you can pick a lot of skills while doing this, which you can use on your regular work. So
Yeah.
I think it's like that.
And how do you manage this time, right? Working on a day job, being so creative on Tableau Public. This is one of the questions, one of the I usually
It's
yeah.
not generally it's not easy, but it's also something which I learned by participating in all of these community projects. Because I remember first time I participated in Makeover Monday, it took me like one whole day of preparing Viz for this. And right now it takes me less than an hour. So
Wow.
it helps me to speed some things up because it's easier to first of all get an idea of what to design, and second how to execute this. So Makeover Monday's datasets are not that time consuming because as you see, I have above 130, I think, visas in Tableau Public, and more than half of them are this Makeover Monday. So for me, it's great that I can keep consistency in publishing on a regular basis to dedicate some small amount of time one day in a week to just keep up and be consistent and learn new things on a regular basis.
Perfect. Thank you, Matsu, for that. Let me go ahead and introduce our next speaker. I think for him, I just have one thing. I think age is just a number for him. So this year he was selected as a Tableau Zen Master. And yep, I think Jim, you are an inspiration for everyone that if you want to go ahead and do something, you have to just go ahead and follow your passion. So yeah, Jim, all yours. Please go ahead.
Well, thank you for that. Mateusz, that was a great presentation. I really enjoyed that. Let me get started here, and you should be able to see my screen right now. Back sometime last year, I made a presentation here on VizConnect, and I called it at that time my 5 building blocks. And I got a lot of feedback from that presentation. They said, well, you really ought to expand that out to a whole series, which I've done. And now we call it a 0 to Zen. And today we're going to go through the third of the 5 sessions that comprise that series. Just a bit of background. I live in Nashville, Tennessee. It's almost 7 a.m. in the morning. I've had some coffee, so I might be over caffeinated. By my background, I'm an engineer. I'm not a data scientist. And as such, I look at things maybe a little different than a data scientist would. I spent about 30 years in consumer marketing, and just in the way of how I got here, my background was all in Excel and Access. I had no background at all in visual analytics. So I started at ground zero, and that's where the 0 came from. And as Sagar mentioned, I'm now one of the Zen masters. Okay. We're going to look at session number 3, which involves calculations and the language of Tableau, or the syntax. Session 1 covered data structure and connections. Session 2 was the order of operation, and I just happen to be presenting this session again on Monday at the analytics user group, and the link for that is in the chat. Okay, today we're going to talk about calculations, and that's actually broken down into 2 parts. We're going to cover calculations, simple calculations, and date functions today. The last of the session, well, LODs and table calculations will be presented next Thursday in the US live, and the link for that is in the chat also. And the final step is what I call the toolkit. It's the filters, the sets, the parameters, and their actions that users can use to interact with their dashboard. Today we're going to cover, there's only 4 basic types of calculations. There's simple counts, date functions, LOD expressions, and table calculations. And today we're going to look at simple calculations and date functions and just how they work. One thing we have to understand is that whenever you bring a measure to a dashboard or to a worksheet, you're creating an aggregation. If you look at the data table that underlies each one of the worksheets, and each worksheet has its own separate data table, there can be thousands of records in that worksheet. And when you bring a measure like the sum of sales based on category to the worksheet, those thousands of records get aggregated down to 3. And the default aggregation is sum. Now I want to take a look at how that happens, and I always use the calculation wizard when I write a calculation. For those of you who are familiar with Excel, this kind of feels familiar. All the possible functions are listed over here alphabetically. They are categorized in groups, so you can look by group. This section over here explains what the function is and how to go about using it. And this is the area where you create the calculation, and you can see as you write in that area, Tableau is going to suggest values that you can put in there. And as I do that, there's a syntax checker. This will check the syntax and tell you when you've made a mistake. And this little squiggly red line that you probably can't really see all that well will tell you about where the error has occurred. And the error here is the most common error that we see, and that's an aggregation area, mixed aggregates and non-aggregates, and you just plain can't do that. If you think about that underlying table where there's thousands of records, I've narrowed this down to 3 records, and this is still at thousands of records, and that just plain doesn't work. So this has to come back and be aggregated. And when that happens, you get a valid calculation. And that's how you go about doing simple math. You know, any type of math function you want to do, you can write that equation just like you would in algebra, if you will, but you just have to remember that you have to aggregate the measures in the calculation. Now, another type of simple calculation is, another type of simple calculation is the if statement. And you've done this quite often, I'm sure, in Excel, but the syntax in Tableau is if a condition is true, then execute the result. And it always requires an end statement. Now this calculation, if we read it, when we look across, I've got a dimension here that's a string. It says if the region is east, and whenever you have a string that you're going to compare to, it has to be enclosed in quotes, and it has to be an exact match. It has to be a literal match. Capitalization has to be the same, for example. Okay, and this says if the region is east, or, and we can use a conjunction, and the conjunctions are or and, or the region is west, and you have to repeat the dimension again. If either of those conditions is true, then call it coastal. If not, and the key word here is else if. If that's not true, else if the region is central, call it middle, and anything else, just call it south. And we can create a new dimension that recategorizes those into 3 groups. Well, you know, I mentioned before that the aggregation that is the default is sum, but there are other aggregations that are available, and you can look at these aggregations just by right-clicking the pill, coming down to measure, and you can see, well, there's sum, which is the default. I'm going to show you average here, but you could use median or count or standard deviation or any of these others as a way of aggregating the data as you bring it to the viz. So I created this rather simple chart here, and I'm looking at quantity, and I'm looking at sales, and I've got average sales. And you can see that this is not sales divided by quantity. This is not the average of what you see in the Viz. Well, if it's not the average of what you see in the Viz, what exactly is it? Well, the aggregation that you get by just using one of these defaults here is actually the sum of all those individual records. This is the sum of those 10,000 records broken down into subcategories divided by the count of those records. And that's, there we go. As we bring that to the Viz, you can see that, yeah, the calculation there, the total sales by the count of the records is that 504. But if you wanted the average that's in the Viz, you have to write the calculation. And we see this type of error come up all the time. People say, well, the rate's not right, or the average isn't right. What did I do wrong? Well, they just dragged average to the measure table and aggregated it average. Now, you have to do the math. And as we noted before, you have to have it aggregated at the same level. So sum of sales divided by sum of quantity will produce the average that you're looking at. And it's more like, oh yes, this makes sense. That's the average of sales divided by quantity. Well, what other type of things can you do with simple calculations? And one of the things we can do is we can use strings, and we can calculate based on strings. And here's an example of a excuse me here just a second, very simple calculation where we're going to use a condition like we looked at before. If the category is office supplies and the category is region, so I might want to see all the sales that happen in the Western region, but I only want to look at office supplies. So I can use the conjunction here and group them together, and I can look at sales, and I get a value like this. But I might also want to count how many customers does that involve? Well, that same type of calculation can be used to do a count, but here we've aggregated a measure. I've got a dimension here. I've got a dimension called customer name, and I'm going to count the customers. And when I aggregate count, I have to come back and aggregate all the other dimensions or measures in that same expression. Well, you can ask the question, well, how do you aggregate a string? Well, there's five choices you have: min, max, attribute or ATTR, count, and count D, or count distinct. Okay. Personally, I avoid using attribute because I like to write a lot of LOD expressions, and you can't use ATTR in an LOD expression. So here the choice was min or max, and when I bring that to the Viz, there's 1,897. I could also write an expression like this, and here I'm just showing you can use ATTR. It's the same expression, but here I use count D. And count D, or count distinct, only counts each customer name once, where count will count every time a name appears. So the distinct customers in the Western region who bought office supplies were 608. So we can use string values in making numerical calculations. There's other things we can do with strings, and I want to open this up so we can take a look at it. I use this as a filter. And let's take a moment and take a look at all the string functions that are available. And if you're familiar with Excel, a lot of these look familiar. You can, there's left and right and length and upper and lower. The one we're going to look at right now is contains. And what this says over here is it contains if this string, which is the customer name, includes these characters, and once again, this has to be a literal exact match, Aaron, it returns a true. So I use this as a filter. I've set it equal to true. And we find there's 3 names of Aaron. Well, if you can do that, is it possible to use strings to dynamically group records together. And yeah, it is possible. And here we're going to use another string calculation. We're going to use left. And this expression works exactly the way it works in Excel. And all it says is, as you look at the subcategory, starting at the left, look at the one character. And if that character is less than or equal to M, call it group 1. Well, how is a letter greater than or less than? Well, for all string values, Tableau uses an alphanumeric sequencing and sorting. So A, B, C, D, anything less than N, anything that occurs in the alphabet before M will be in group 1. If that's not the case, else if the character is less than or equal to R, it goes in group 2. And note, I don't have to write else if the character is greater than M and the character is less than R. And the reason I don't have to do that is because any type of conditional statement is processing each record individually from that data table that underlies this worksheet. And as soon as that record returns a positive value on a condition, it executes the then, and then Tableau moves on to the next record. Very often we'll get people that will gang conditions together and they don't know why it didn't pick up all of them. Well, it's only going to check the record once. And once it returns a true, it does it executes the then statement. So we're able to group these into 3 groups. Well, the next question comes, if I can do that with dimensions, can I do the same thing with measures? And there's a couple of ways of doing it, and I'm going to show you one way today, and that's by using bins. I right-click, create bins. A window will open up, and as that window opens up, I can either use a parameter or I can set a value in here, and I'm going to group the quantity into bins of 2. Okay, and we can look at that, and here it has become a dimension. It says quantity bins is a dimension now, and I can bring that to columns, and then I can count orders against it, or I can count customers against it, and create a histogram. Okay. Simple calculations are the simple calculations that we've looked at. We'll show you how to do, a little bit of math. Just remember, you have to do aggregations. We also showed you how you can use if-then statements, and you can read string values and use those to group items together. We also saw how we can create bins, or we can create a dimension out of a measure. I want to move on to date calculations, and that's the second part of what we wanted to talk about today. Dates are a very special type of dimension in the sense that dates are actually dates or date times. Dates know how to self-sequence, and dates work exactly like they do in Excel. Dates come in a hierarchy, and that hierarchy starts at year, quarter, month, day, and you can think of that as an integer value in a floating point number. And the decimal part are hours, minutes, and seconds. And you can use any of these date parts in a number of date functions to identify which year it is or what month it is and the like. There are also 3 date parts that are not part of the hierarchy. Week is not part of this hierarchy. Weekday, and it's like Sunday, Monday, Tuesday. Weekday is not part of the hierarchy, but you can use it in a date function. And very seldom use day of the year, and it's something that I use on occasion. January 1st is the first day of the year. Most years, December 31st is the 365th day of the year, and then on a leap year, it's 366. Now we can use those date parts in a series of date functions, and those date functions can be grouped into 4 categories based on what they return. There are functions that return an actual date. Date trunc and date parse return a date, like April 23rd. Or actually, date can return a date time. It can return the time of day at the same time. There are those functions that return a reference to a date. date name returns text, like date month will return the names January, February, March, April. Date part, year, month, day, and week return an integer value. Like date part month for January is 1, date part December is 12, and so on. There are those functions that do date math. I can increment a date by adding something to that date, or I can take the difference between two dates and get an integer value in return. And then there's two special functions today, which is the date value, like today is April 23rd, 2021, or now, which returns date time, and it's April 23rd, 2021, and my time is 7:10 a.m. Okay. I caution about using the now function if you're working with a live database, because that can, every time the time changes, it can create, it can change your values. And that can be very confusing. Let's see how some of these date parts work. And we're going to go through rather quickly. I just made this simple chart. I wanted to look at months and days in the year 2019. And we created this, hang on one second. We created this calculation that looks at date part. Now let's look at all the date functions. And there's a whole load of them here. We're looking at date part at the month level, okay? And we're looking at the order date. So the date part month is going to return an integer. And the integer returns is 1 for January and 12 for February, or 12 for December. We could have looked at date name, and date name would have returned the text, as I noted before, January, February, March, and so on. Date name is great for doing labels. Date part is what you want to use if you're going to do math with the date. Well, if that's what date name and date part do, what does date trunc do? Date trunc, and this is my absolute favorite date function to use when I'm creating ranges. Date trunc returns the first date at the level that you're looking at. So date trunc month order date is going to return January 1st, 2019, February 1st, March 1st. If we look at the quarter level, the date trunc at the quarter level for January, February, March is the first day of January. That for the second quarter, April, May, and June is April 1st, and so on. It's a great way to group dates together. And let me just show you an example here real quick. If I wanted to determine the year-to-date values, we could write an expression like this that looks, in the way you would read this, it says, look, if the date trunc of year of the order date, if the first day of the year of the order date equals the first day of the year today, then they're in the same year, so that's going to return a true. And I also want to take a look at, is the day at the day level order date less than or equal to the day today? If that's the case, then I want sales, and that's going to return this year-to-date sales. If we take a look at last year-to-date sales, the same type of formula, but now we're going to do a little date math along with that. It starts out the same. We're going to look at the year level of the order date, and I want to look at the year level of, and here I add a -1 to today, date add -1. I'm doing date math instead of look back 1 year. 1 year, same date last year. If that year is equal, that's going to be a true. And once again, the day value is going to be the same, except I'm going to look at last year. And when we do that, we can get the sales for last year. And you can take the difference in those numbers and we'll write the equation. I'll probably make some mistakes doing this. Oops. and then return the difference between the two numbers. I would do that using LODs, and I'd explain why in the next section that we've got that coming up. Well, we looked at the whole numbers and how to work with date parts with the whole number part, days, months, years, quarters, that sort of thing. How about time? I've got a different data set here, and I want to look at this data set. And what I want to do is I want to look at the difference between the start date and the end date. And these start dates and end dates are minutes apart. So I could write an expression, and this is the other expression that we'd use, date difference. It's a date math function, and it looks at the difference between these two dates. And it looks at the difference at the minute level. And I guess I should mention that this argument is always lowercase. It's always enclosed in quotes, and it's always singular. So we don't look for minutes, we look for minute. We look at the date difference at the minute level between the start and the end date. And that's what you see here. And you can look and you can say, well, that's 11:12 and that's 11:19 and change, and I get a number of 7. Well, why do I get a number of 7? Is that number rounded? The number isn't rounded. What Tableau will do, as it looks at each one of these levels, it truncates the date values, or in this case, the time values. It truncates that value at minute. And it takes the difference between that truncated value at minute and returns the value that you see there. So 19 minus 12 is 7. Well, that might not be what you wanted to see. You might want to see something at a minute and second level. Well, I can take a look at the difference in seconds, and Tableau is going to return the total seconds. Well, that's probably not what you wanted to see either. I can do the math, and I can take the difference in seconds divided by 60, and I get a floating point number where I get, like 1.7, 7.5, and that's not what you want to see either. You probably wanted to see something that looked like this. I want to look at 7 minutes and 31 seconds, or 1 minute and 35 seconds. Well, we can create that. And first thing you have to understand is this is going to be a string value. It's no longer a number, it's a string value or a text value. And we create that by starting with the minute calculation. We're going to take the integer part of the seconds divided by 60 like we just saw, and that's going to be minutes, and we're going to concatenate that using the plus sign. And this is a literal string, so it's in quotes again, space, minutes, space, and then close that. And then I want to look at the seconds value. And here I'm going to use a function, and I always mispronounce this. The function is modulo. I think that's the way it's pronounced. And what that function does, and you won't find it over here, what that function does, it returns the remainder of taking this argument, the seconds, and dividing by 60. If you remember doing division when you were in school, or at least I did with a pencil, and Sager noted I'm kind of old, so I did it the old school way. He ended up with a remainder. Well, it's going to return the remainder, and that remainder is the seconds that we're looking for. So by putting that together that way, now I can look at 7 minutes and 31 seconds, or 2 minutes and 40 seconds. But once again, those are string values. You can't do math with that. But what other types of things do people like to do with dates? Well, we like to chart them. We like to put them on graphs and that sort of thing. Well, dates have a unique function or a unique property that they can either be discrete or they can be continuous. And if I just drag order date to columns and expand it out to months, I'll get a chart that looks like this. And we'll get all kinds of questions on the form. It's a repeated question. See, I want that point to match up with that point. How do I get this thing to match up? Because I can't show my user something like that. Well, we can do that by making a continuous chart. Now, I'm just right-clicking this value and dragging it up to columns. And when that window opens, and you can see this window, that's opened. I hope you can see this window that opened. You can see this window that opened, and the top part of this window are the discrete date parts. And you can tell because it's got a pound sign here and it's blue, and we could choose the date part that we want to see discretely. The bottom part are continuous values. And you can tell it's got the date time symbol, which is the calendar and the little clock. And I'm going to look at month, and they're also green. I'm going to look at month. And when I do that, we get the same chart, but those points are connected together. Now, you may want to look at this discretely because people will ask to say, well, I got some white area here and I got some white area at the other area, and I really don't want to see that. I can actually take this and convert the continuous into a discrete value, but it's not going to be the discrete date part. It's just going to plot discretely on the map, and everything's still connected. And I can also come back and I can drill up and down in this by using the plus and minus symbol, by drilling up and down in the on the axis itself. So we learned how to plot data, or plot dates. Well, when is a date not a date? Very often we'll get a question. A user will call right in and say, "Hey, I've got a data set, and in that data set, I've got year, I've got month, I've got day, but I can't seem to make it plot the way I want it to plot." And my advice to them is always the same. It's always convert it to a real date. You don't have a date in your data. You have strings and you have numbers, but you don't have a real date. Convert the date to a real date because it self-sequences. You can use it, as we just saw, either discrete or continuous. They know how to sort. They know how to make maps. Date works very well for doing that sort of thing. And you can use date functions. So I've got a data set out there that looks like this, okay? And it's got a month, it's got a year, and month is a string value, and year is a number, and quarter is a number. And I've also got this that, I don't know, in the US, we see a lot of accounting software that uses this kind of nomenclature, and it's a string value. You know, the first quarter of 19. And the question is, how would you convert this to a real date? And we can look at this as a way of doing it, and we're going to use a function called date parse. This is another function. Date parse. First, you specify the format that you're going to give this function, the format for the date that you're going to give the date parse function. And what we're going to look at is the first 4 characters are going to be the year. The next 2 characters, the capital M, means I'm going to give you those, and I want it returned as a month. And the last 2 characters are going to be the day. Well, to do this, we're going to take a look at this period, which is that 2019 and the quarter. So quarter 1, quarter 2, and quarter 3. We're going to use initially another string function. We're going to look at the left, starting at the left, take the first 4 characters, and that's going to return a string, and that's going to be my year. That's going to be those 4 characters. I can concatenate plus sign, and I can concatenate the dash and put the dash in. Then I came back with this other type of conditional statement. This is like an if statement, only different. It's a case statement, and it says, I want you to take a look at these right 2 characters in period. Take a look at these 2 characters, and when that's Q1, return 01 for January. When it's Q2, return 04 for April, and Q3 is July, and so on and so forth. And end, and that's going to be these 2 characters, the month, and then for day, I just want to use the first day, and I concatenate in a dash and then put in 01. And when we bring that to the Viz and look at month, day, and year, we can see we're getting the month the day and the year, and the month is spelled out as January. And it's a real date. And now you can use real date functions with that. You can use date functions with the real date that you couldn't do with the pieces part. I want to take a look at one final thing here real quick, because we talk about fiscal years, and you may have done this yourself, where you open up the date and you take a look at default properties and fiscal year start, and you can set the start date, the start month for the fiscal year, and this is set at July. So you can see the fiscal year 2018 runs from July to June, and so on and so forth. Now, the one thing you have to understand is that the fiscal year is great for presentation, but you can't use any of the date functions with fiscal year. Now, for example, if I wanted to look at year of order date here, and I just wanted to drag it to the Viz here, you'll see that 2017 starts in January and it runs through December. The date functions are based on the calendar year, not the fiscal year. If you want to do year-over-year analysis, or particularly quarter-over-quarter analysis, it can be quite complex. But I have a post on my blog, and that information is in the chat. I have a post on my blog on how to go about doing them. Sager, I think I've used up about our time here. I do have a little bit of time for questions, I believe. And I'm going to stop sharing my screen now, but if you have questions.
Sure, Jim. First of all, Jim, thank you for covering those. I think that was important for everyone just to understand the foundational knowledge of all these functions in Tableau. So yeah, thank you. So Tim has a question for you. When and why to use custom date?
Okay, I use custom date, and if you saw me do that right click and that window opened up, those are actually custom dates that you use. I use custom date because I can control the format a little bit better with the custom date, and it's not going to. It works the same in all the date functions and the date calculations, but you can control the format a whole lot better. Also, to be honest with you, just right clicking and dragging like order date up to columns and that window opens up, it saves me a step along the way. It's a little bit faster to do that.
Perfect. Thank you, Jim. I think Neha is asking for your blog. I'm just pasting it. It's the same one, right? jimdehner.blogpost.com. That's the one? Your blog?
My blog?
Yeah.
Let's see. I will put the blog. I will put my blog in the chat here.
Sure. Okay.
In just a second here. I see a question came up about explain date and when to use date and make date and that sort of thing. Make date and make date are actually they're actually data type conversion. They're not date function. They're data type conversion. And you can look under the conversions to see how those are structured. Be careful. Make date you cannot use with some live connections. When you're connecting to some live database, they won't accept make date. And in those cases, you can use date to convert, again, strings and numbers to a real date. Other times you can use make date, but that's strictly a date conversion. Date parse works with any data source.
Perfect. I'm just seeing if we have any questions.
Okay.
Oh.
I just want to drop this into the chat real quick. Jim's blog. You can go out to my blog. There's a number of articles out there. There's also a word cloud that can kind of lead you around. Look under physical Yeah, yeah, thanks, Tim. Look under fiscal year, or fiscal dates to see the fiscal year conversion. Also look under FAQs, and a lot of things will come up and tell you how to see common errors that we see and how to relate to those common errors. Okay.
Perfect. Go ahead, Jim.
Okay, I think if there's any more questions, I'm still available for questions.
We can take one last question if you have any question for Jim or Matsu. He's also there on the line. If no, then we are right on time. So I think with that, thank you, Matsu. Thank you, Jim. It was an honor to have you on VizConnect. And thank you for sharing all your inspiration and passion about Tableau. With that,
thank you for the opportunity. It was great meeting you all.
Perfect. With that, thank you everyone for joining this session. Be safe,